Good morning, ladies and gentlemen. Today we are on page 163 of your student journal. And our objective or our goal is today I will solve multi-step word problems with mixed numbers. Okay, so in our last video, we solved problems with mixed numbers. Today we're going to have multi-step word problems with mixed numbers. So multi-step means that you might have to do more than one step. Multi means more than one step. Okay, a couple reminders of our vocabulary is this is an improper fraction when the numerator is greater than the denominator and its value is worth more than 1. And this is equivalent to 1 1/4. And the reason it's equivalent to 1 1/4 is because 4/4 is equal to 1, and then because there was 5, there's 1 extra. So 4/4 is 1 and 1, 1 1/4. Okay. And then it reminds us what a mixed number is. Okay, our steps today I'm going to be following pretty closely when I do my examples. So it says determine what is being compared by using a T-chart. I don't know if I think what we're using the word compared. I'm just going to say use a T-chart. So I don't know if I like the words determine what's being compared, but I do like using a T-chart for these word problems. And then it says fill in the chart with known information and determine the operation. So this kind of all goes together. This is like one step. So make a T-chart and we want the information and the operation in our T-chart. And then we're going to solve using a number line, an area model, or the commutative property. I prefer the commutative property, so that's what I'm going to be using. If you preferred a different strategy, you're welcome to use a different strategy. And then we're going to write the fraction equation and solve. So pretty much we're going to make our T-chart, use our commutative property, and then solve. Okay, so what does my first one look like? Here's my first problem, and it says, Leon mailed a letter on Monday morning. The letter traveled 6 4/12 miles on Monday. It traveled 8 9/12 more miles on Tuesday. On Wednesday, it traveled 2 8/12 miles before reaching its destination. How far did Leon's letter travel in all? Okay, so what the T-chart is kind of, I'm going to pull the information out of here. So he mailed a letter on Monday and it traveled 6 4/12. And then it traveled 8 9/12 more miles on Tuesday. So more would be, I'm going to add that. Add 8 9/12. And then on Wednesday, it traveled another 2 8/12. So that's another adding, 2 8/12. Okay, so the T-chart, I kind of pull my numbers out and then I determine, am I adding these or subtracting? Okay. And then my question is, how far did Leon's letter travel in all? Well, because it's all adding, I'm actually able to add 3 numbers at one time. So I can add all these numbers at one time. So I have 6 4/12 plus 8 9/12 plus 2 8/12. Now remember, if I'm going to use the commutative property, I first decompose all my numbers. And then I use the commutative property to rearrange them and put all the whole numbers together and all the fractions together. And then I'm going to add my whole numbers. So 6 plus 8 plus 2. I'm going to do 2 plus 8 is 10 plus 6 is 16. And then my fractions are 4/12 plus 9/12 plus 8/12. Well, 4 plus 9 is 13 plus 8 is 21/12. So I have 16 and 21/12. Okay, now 21/12 is an improper fraction, so I need to fix that. I'm going to come up here because I'm kind of running out of room. So 21/12 is equal to 12 out of 12. And then if I took 12 from here, how many would be left? 12 plus what equals 21? 9. So 12/12 is 1 whole. So 21/12 equals 1 9/12. So if I add that to my 16, it's 17 9/12 is my answer. Okay, let's look at my next one. It says a bucket contains 5 1/6 gallons of water. If Dulcina adds 3 1/6 gallons more to the bucket and Alexander takes 2 4/6 gallons out of the bucket, how many gallons of water will be left in the bucket in the end? Okay, so what do we have here? We have the bucket, and how much is in the bucket? 5 1/6. And then Dulcina adds 3 1/6. So that's an addition. She adds 3 1/6. But then Alexander takes 2 4/6 away. So Dulcina takes 2 4/6 out of the bucket. Okay, so what do we have here? Well, so we can add, we can't do all this at once because we can't add and subtract in the same problem. So we can add first. So let's add those first. So we get 5 1/6 plus 3 1/6. Which if I'm going to use my commutative property, I'm going to decompose them. And I get 5 plus 3 plus 1/6 plus 1/6 equals 8 plus 2/6 equals 8 2/6. Okay, so that does not have to be, I don't have to fix it because that's not an improper fraction. It's just a regular, so I'm okay with that. Okay, but that's only one step. I just added what was in there, but now I have to actually subtract. Okay, so now I'm going to have to subtract, and if I have, my next problem is going to be, now I have, this is how much is in the bucket, 8 2/6 minus, what does Alexander take away? 2 4/6. Okay, so this one is a little bit trickier because I'm going to have to do some more decomposing. If I wanted to use the area model, I'm sorry, not the area model, the commutative property. I'm going to get another piece of paper because if you see, I'm going to run out of space. So I'm going to reset this problem up with a little bit more space. So I have 8 2/6, and then Alexander is going to take away 2 4/6. Okay, so let's use our commutative property, but that's for commutative property for addition. So I think actually for this one, I'm going to use an area model. So let's see, what do we have? We have 1, 2, 3, 4, 5, 6, 7, 8 holes, and I have 2/6. So let's divide this. Okay, so this is what's in the bucket, 8 2/6. I don't know why I said I would use commutative property. That's only, commutative property was for the addition, not for subtraction, sorry. Okay, so this is what we have. We have 8 2/6. Okay, they want us to take away 2 4/6. Okay, so if I go to take away the 4/6, look what happens. I don't have enough. So I can only take away those two, which means I need to cut up another hole. So I'm going to cut up another hole into 6. So they want me to take away 4 parts. So I took away 2, now I took away 4 pieces. Okay, so I took away the 4/6. They also want me to take away 2 holes. So 1, 2 holes. So what do I have left? Well, I have 1, 2, 3, 4, 5 holes. And how many pieces do I have left, or parts? 1, 2, 3, 4 out of the 6. So my answer is 5 4/6. Okay, let's try some together. Right now we are on page 164. And here is our first one. Kid and Molly went on a road trip. On the first day, they traveled 112 3/8 miles. On the second day, they traveled 154 2/8 miles. On the third day, they traveled 99 1/8 miles. How many miles did they travel all together? Okay, so let's do our T-chart. So on the first day, they traveled 112 3/8 miles. On the second day, they traveled more. So we're gonna add 154 2/8 miles. And then on the third day, they traveled more. So that's gonna be an add 99 1/8 miles. Okay, so since this is addition, I think the easiest thing we should do is the commutative property. Okay, because they're all adding. So we could add them all at once. So we have, let's first set up our equation. And then let's decompose, which means we break up our fractions from our whole numbers. And then let's use the commutative property of addition to rearrange them. So let's put all of our whole numbers together. And let's put our fractions together. 3/8 plus 2/8 plus 1/8. Okay, then let's add our whole numbers. I can't do this in my head, so I'm gonna find a separate spot and kind of work that out because that's a lot to add. So I might come up here and say 112 plus 154 plus 99. What do we get? 2 plus 4 is 6. 6 plus 9 is 15. 1 plus 1 is 2. 2 plus 5 is 7. 7 plus 9 is 16. And then 1, 2, 3. So my whole numbers are 365, and our fractions are 3/8 plus 2/8 plus 1/8 is 6/8. And then when we put those together, we get 365 6/8. 6/8 is not an improper fraction, so we can leave it alone. Okay, let's try our next one. Okay, we have Aaron made some bean soup in a pot. He used 1 3/6 cans of black bean soup, 5 1/6 cans of tomato soup, and 2 cans of broth. When the soup was ready, he gave 2 5/6 cans of soup to take home. How much was gave to Katie 2 5/6 cans of soup to take home. How much soup was left for Aaron? Okay, so let's make our T-chart. Okay, so first he added the black beans, so that's going to be an add. He started with black beans, then he adds the tomato soup. So the tomato soup got added, and that was 5 1/6. Then he added 2 cans of broth. So he added 2 cans of broth. And then he made the soup, and then he gave Katie 2 5/6 cans to take, or cups to take away. So he added these ingredients, but then he took this away. So we're gonna have to do kind of 2 steps. We could add first, and to add I might use the commutative property because I feel comfortable with that one. I'm gonna decompose first. And then I'm going to use the commutative property to rearrange my whole numbers and to put my fractions next to each other. Oh, that should be a 1. Sorry, ladies and gentlemen. Then I'm going to add my whole numbers, and I get 8. And I add my fractions. 3/6 plus 1/6 equals 4/6. And then we can combine them. So that's how much soup he made, is 8 4/6. Okay. So he made that much soup, but then he gives Katie some. That's a subtraction problem, and I ran out of room. You're probably running out of room too, so you might need to pause the video and get some separate paper. But this is how much soup's in the pot, and then he's gonna take away this. So I'm gonna set that up as a subtraction problem. 8 and 4 6 take away 2 and 5 6. Okay, and I think for the subtraction problem, I'm gonna use the area model again, because to me that's the best way to subtract. So what do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, and I have to cut this into 6. So I have 1, 2, 3, 4, 5, 6, 7, 8, and 4, 6. That's what we have. And they want us to take away 2 and 5 6. So I have to take away 5 6. So 1, 2, 3, 4. Okay, I don't have enough to take away, so I need to cut or partition another one into 6. If I already took away 4, I just need to take away 1 more. So now I took away 5 6, and they also want me to take away 2 wholes. So what are we left with? 1, 2, 3, 4, 5 wholes. And we're left with 1, 2, 3, 4, 5 out of the 6 pieces. So that's how much soup Aaron has left, is 5 and 5 6. Okay, ladies and gentlemen, you have some pages to try on your own. Have a great day.